Hello everyone, welcome to Linked Frequency. I am Vaibhav Sugandhi, and in this particular tutorial I am going to talk about how to build an embedded system. The major difference between previous tutorial and this tutorial is all about there we integrated two sensors and two actuators just to realize how to combine them with respect to software and hardware. But now we are going to talk about building an embedded system, which is realistic as much as possible and understanding the algorithm in the perspective of product in end user. We are not just going to integrate sensors and actuators, but we are going to understand how to design an embedded system with the perspective of end utility. Without further delay, let's get started. Alright, welcome to this screen, and I'm going to show you how exactly we have built this embedded system, which looks like a little bit complicated one, but I'm sure if you have watched a previous video, it is not going to be such a complicated one to understand or maybe build one. Okay, so quickly explaining you what exactly this embedded system does and what is the intent of designing this particular circuit. First of all, we have a push button here which is used as an on-off switch. Of course it is a push button, but I'm going to use it as triggering on and triggering off the entire system with the software controlled on-off control, or you can say to turn on the system we are going to use the same push button, and to turn off the system we are going to use the same push button. Along with that, I have used a potentiometer to control the speed of a DC motor which I have connected through this particular TP120 transistor. Again, a TP120 transistor is a bit new to you, and I understand it is kind of a new circuit and everything, but do remember guys, this is just nothing but transistor as a switch circuit which I am using with TP120 transistor available in Tinkercad, and I'm using a 10 kilo ohm base resistor, base to emitter resistor, and there is a 1 kilo ohm resistor which is connected to base, and the other end of the resistor is connected to one of our GPIO. The most important point here is all about connecting to PWM GPIO. We are not going to use a general GPIO. Instead, I'm going to try and use a PWM based, because we want to control the speed of this particular DC motor. It looks like a gear motor, but no, it is just a DC motor, because we have two terminal. It is not a stepper motor and it is not a servo motor, because in servo motor we have a 3 pin. One is VCC, another one is ground, another one is signal pin, which works on the PWM by default. And in stepper motor we will be having a unipolar and a bipolar, where we are having a 3 wire or 5 wire based on the configuration and brushes inside. But right now we have a DC motor here which is having only 2 polarity pins or 2 pins. One is VCC, another one is ground. I am controlling the current flowing through this particular DC motor by using a TIP 120 transistor, and it's a quite simple circuit. So after this we are using RGB LED just to utilize the component available and make sure that you understand how to integrate actuators, sensors, and build an embedded system. Okay, so one important thing is since we have resources, that doesn't mean you have to use it. Considering that point in mind, in this RGB LED I am only using red color LED and a blue color LED. I am not going to use a G color LED or maybe a green color LED. Just because it is there, I need not to use it, but in your case, when you are building your own system, you can literally use it however you want it. But right now in demonstration I am not going to use it. So first of all, this potentiometer is ranging from 0 to 100. I remapped it. It is already a 0 to 1023 because we are using a 5 volt reference here, and when 5 volt and 0 volt is referred, then obviously our 8-bit ADC or 10-bit SAR ADC inside Arduino development board is going to convert that value from 0 to 1023. However, I'm using a new function or new instruction I want to call, and that instruction is all about map function. When we are calling that map function, we can convert the range of value between 0 to 1023 into 0 to 100 or 0 to 255 for that matter. So right now I am using a 0 to 100 configuration, so where this potentiometer directly controls the speed of this particular DC motor. Of course, I'm going to show you a demo and I'm going to explain you entire code and architecture of the code, but this is a demo or introduction about the circuit that I have built. I think if you have followed our previous tutorial, 6 to 7 tutorials I spent on explaining on this Tinkercad platform and with respect to Arduino Uno development board, considering that, I believe you are going to understand this one very easily. Now let me jump into Arduino code and let me explain you how exactly we have built this particular code. It looks complicated, but to be frank, quite easy if you have followed the all learning process previously, whatever I have shared in the previous videos. Okay, first of all, we have a preprocessor directives which are quite important to make our code organized and looks professional. Okay, so first of all, we are using a button pin here which is connected to 13th pin of digital pin of Arduino Uno development board, and then we have R LED, B LED, G LED. Again, we have declared this G LED pin in program. That doesn't mean you have to use it, but do remember, when you are declaring this kind of variables or maybe a constants by using data types other than hash define or other than preprocessor directives, it is going to consume memory in your entire hardware. So be cautious about when you are using some variables or something. If you are not using them, it is better to delete them, but right now since it is a preprocessor directive, I'm just not caring about it much. Okay, thereafter we have a motor pin where it is connected to again base pin of the tip 120 transistor, and then we have a pot pin which is connected to A5 pin of the Arduino Uno development board. Of course, we can connect it to A0 pin, but in my case A5 pin is quite easy to connect because it is nearby when we are taking this track. A little bit complicated circuit, so wiring I just wanted to make it as clear as possible and as easy as possible so that you can understand it and you can build it by yourself instead of searching where that wire is going on and all. Instead of looking at a wire, I think you can look at the code and you can create your own circuit without looking at my connections, right? So keeping that in mind, these are the preprocessor directives. Thereafter we have one global variable which is a bool type data type based global variable which is all about button flag. Why I am using this particular variable I'll explain in coming part of the video, but do remember there is a necessity of global variable here. Thereafter, in setup, what we are doing, we are going to configure all these GPIOs as input and output based on the peripheral connected. I hope you guys are very much familiar with sensors and actuator. If it is a sensor, then it is going to be input. If it is an actuator, then it is going to be output. So pretty much button pin is going to be input, R LED, G LED and B LED are going to be output because they are actuator. In the same way, motor pin is also output because it is a actuator which converts electrical signal to mechanical. And then we have a pot pin which is again analog sensor. So it is not necessary to write this particular instruction. Why? Because all analog pins are by default configured as input pin in Arduino IDE especially. But for sake of understanding, to keep it professional and keep it easy to understand without having confusion, I'm just keeping that particular instruction in front of you. Okay, thereafter we are going to declare this one of my favorite serial.begin and serial.println with a welcome to embedded system message. Okay, thereafter what we need to do is we need to jump into loop, and now here is the point. The major difference between previous tutorial and this tutorial is all about how you are going to build an embedded system. Major difference is all about this one. When you are building an embedded system, you must have an idea what are the end application of this particular project or maybe the product that you are building. For this particular tutorial, I am taking one simple application just to make it easy for you to understand. Whenever you start a system, there is a motor which should be controlled by a digital potentiometer. Digital in the sense the analogous data that is generated by potentiometer is ranging from 0 to 5 volt because we are using a digital voltage, that is a DC 5 volt. Because of that I am calling it as a digital control. Okay, but in technically that's not a digital control, it is an analogous control. However, let me make it very simple and easy to understand. So whenever we change the range between 0 to 100 or 0 to lower to maximum pole of the potentiometer, it should control the RPM of motor. That is the end application, that is application hypothetically I have created for this particular tutorial. You may consider you have an industry, and in that industry there is one machine which is running with one DC motor, and that DC motor should be controlled by a person who is standing outside, and the system should be turned on and turned off digitally, though without turning on and turning off the main power. Okay, in that case this particular project suits best as much as possible because it has a push button. Even after turning on the entire system, though your microcontroller is running, though your entire system has a power, DC motor and push button and DC motor and your potentiometer is not going to work until and unless you start the system. How do you start the system? By clicking using that push button. You are going to trigger the system by using a push button. And again, how to stop the system? By using the same push button. So that is the beauty of this entire embedded system building. And that is the core difference between two sensor, two actuator integration tutorial that we have done. In previous tutorial, what we did, we just integrated the sensor and actuator, and we wrote a code for realizing how they behave with respect to in a single system. But right now we are creating a purposeful project out of this. That is the difference between embedded system design or whatever the application circuit that we are developing in comparison to previous tutorial. So theory is enough. Let's talk about the entire code. First of all, I'm just trying to make sure that our LED, which is a red color LED, is going to turn off initially, because I just wanted to make sure that when you are going to turn on the next LED, the previous LED should be on, should be off actually, because you want to differentiate the color, right? When you have a red color LED and when you have a blue color LED, it will create another color when both are present. That's why I just wanted to avoid presence of both the color. That's why I just wanted to turn off the red LED first time, and then I am going to call one user defined function which I already explained in previous tutorial. And this user defined function, which is nothing but a button call, which will read the signal from the push button, and if the push button data is low, that means whenever you are pressing, it is going to generate a low signal. Along with that, I am using an AND operator here, which is a Boolean operator or a Boolean logical operator, we call it as. Along with the push button pressed, if it is pressed for the first time, when this button flag is high, because when we declared that button flag here as a global variable, it is high by default. Okay, so for the first time, whenever you are declaring or whenever you are entering into the system, it is by default high. And when you press the push button signal becomes low. On that time, this button flag will be converted into low, so that your main loop will understand whether you press the button or you release the button, all those things. And you are going to print a small message here which is all about system started. Okay, when your button flag is low, because you have converted that high state into a low state by pressing the push button, it will enter into this particular while loop, because while loop condition is all about button flag is equal to low. Okay, initially it will not enter until and unless you press the button. Once you press the button, that button flag variable or button flag global variable which I have created on the top will be converted into low, because of which it will be entered into a while function or while loop, we call it as. Okay, so when we enter into while loop, there is no way that the button flag will be converted back into high. That means it will loop in this in the same function and in the same loop, and it will not come out of it. To avoid that, we are calling the button call at the end of every iteration to check whether you want to press the push button once again. What happens if you press the push button once again? I'll tell you. When I go back to user defined function called button call, you can see that else if function is also written here. So else if condition, basically not function, else if condition within this button call function. What it is doing when your button state is low, that means when you are pressing the button along with when the button state or button flag is low. Means when you already pressed the button and system started, system is executing, on that time if you are pressing a button once again, it will stop the system. That is what the message is here. stop the system, or maybe a system stopped. Along with that, it will make sure that all the LED or motor pin is turned off, so that there is no malfunction in the entire system, and it will wait for some second and it will come out of this particular user defined function called button call. On that time, when it is coming out for the second time, in the second case which I am explaining, the button flag is going to be high once again. When it is high, this while function will be broke. It will not execute because the condition is false. When the condition is false, it will not execute these instructions. This is how we are going to use push button, which is only one push button to control the system by turning on and turning off by pressing the push button. Okay, this is the wonderful way which you can realize by using a single push button. Of course, you can use a slide switch or two push button to turn on and turn off, which is easiest way, but this one is a little bit challenging, and I want you to explore such kind of challenging thing to understand it much better way and much professional way. Okay, thereafter, when let us say that you started the system, you want to read the data from the push button, or not push button, from the potentiometer. Okay, because we want to control the speed of DC motor, right? When the potentiometer is having a range between 0 to 1023, there is one function which I have called, or which I have used for the first time in the entire tutorial, which is so called map function. By default and built-in function within Arduino IDE, which will range this data, whatever the pot data coming from 0 to 1023, we can give a range here, 0 to 1023 will be mapped to whatever the value you want to write it here, either from 0 to 100 or 0 to 255, whatever for your choice. But purposefully you have to choose it between 0 to 100 or 0 to 225. The reason is, this analog write instruction works with 8-bit DAC, or 8-bit PWM signal we want to call. When it is 8-bit DAC, it is not going to exceed the value from 255. So you have to do everything that you want to do within 0 to 255. So either do it as a 0 to 255 or do it as a 0 to 100. As per your choice. Right now I am choosing a 0 to 100. There is no technical reason for that, but I just choose to go with 0 to 100. This function will convert this data, pot data, into a new data which is ranging from 0 to 100 based on the position of the wiper, and that data is stored in one more variable called new pot data. I'm just creating one more variable for sake of your understanding. Thereafter, we are going to print that new pot data on serial monitor so that we can understand what exactly the value is going to that particular GPIO by using another instruction called analog write. By using analog write instruction, we are sending a specific PWM signal to that motor pin which is connected to base pin of the tip 120 transistor. Thereafter, we are going to turn off the B LED and then again wait for 1 second and then call a button call function to check whether you are intend to press that push button to stop the system. Otherwise, it will continue. Again, B LED will turn on, the blue color LED will turn on, and then wait for 1 second, and then it will check the potentiometer data, whether it is same or changed, whatever it is. If you have changed it, it will consider it. Otherwise, it will go with the previous value, and then again it will map it to 0 to 100, and then again it will send that particular data to serial monitor to print. Along with that, it will also send it to motor pin with a PWM signal, and again B LED will turn off. This cycle repeats again and again until you press the push button to stop the system. This is how the entire embedded system is built. I would like to show you how this entire system works. I'll just copy the code from Arduino IDE wherever I built my software, and then again I'll go to a Tinkercad software where I'll click on the code section, and of course I have tested it, and I have cleared all the code here just for making it very new view to you. So I am just pasted the code here, and there is no control yes here. I hope you are having that muscle memory too. Thereafter, I'm just going to click on this start simulation. Along with that, I just wanted to bring this system a little bit here so that you can visualize it. I would like to zoom in a little bit so that you can visualize it much better way, because we don't need to see the Arduino board. Most important thing is all about this breadboard. Now you can see that welcome to embedded system is printed on a serial monitor. That means the system is started. Technically it is started, but the actual data or actual system that we want to operate, that is all about controlling the DC motor, is not yet started because we have not pressed the push button, right? So you can see that the red LED is blinking, just to indicate that the system is already on. Okay, the moment when I press on this push button, you can see that I just need to hold it a little bit long because I have added a lot of delay in between, right? So now you can see that system started message is displayed on the serial monitor and the LED color got changed to blue. Okay, I hope now you are understanding what is the connection between the code that we have written and whatever the output we are expecting here. Now you can see that the potentiometer value, which is the scaled value 0 to 100, whatever we have scaled, it is a 26 value. At 26 value, the RPM of this particular DC motor is ranging between 800 to 900 somewhere. It is fluctuating continuously, but yeah, you can notice that. Now I would like to change the potentiometer value to somewhere 57. Now you can see that the RPM of this DC motor got changed to 2000. Yeah, approximately 1700 to 2000. It is fluctuating too much because of this B LED, because maximum amount of current is flowing through B LED and little amount of current is going to our DC motor, because of which it is fluctuating with the RPM. But you can clearly notice that there is a huge difference between 800 to 1000 to 1700 and all those things, right? Just by changing half the Viper. Let me make it a full scale, which is 100%. When it is 100%, you can literally notice that it is 3200 RPM. A very good DC motor, I guess. Okay, practically also there are so much DC motors available, and you can literally use this circuit and this particular code to control the physical and realistic DC motor as we built on this Tinkercad platform. But just for the sake of this video, I am using an online simulation tool. Okay, now let me make it back to 0, I think, or maybe let me keep it somewhere in between, like I just wanted to cross verify. So now it is a 47, and you can see that exactly the value is half of the 3000, somewhere around 1500, 1600, something like that. Now I want to stop the system. There are two ways to stop the system. Of course, we can click on stop simulation, which I'm not going to do, by the way, because we built an embedded system which is smarter than whatever we have built so far. Okay, I'm going to click on this push button once again, and you can notice it is going to stop by itself. Whoa. You can see that system stopped and RPM of this particular DC motor is back to 0, and there is no data fetching from this particular potentiometer, and you can see that red LED started blinking back to normal. That is how you build an embedded system. That is the core difference between whatever the circuit you have built so far and whatever you are building now. Now you are building application out of whatever you have learned so far. It is not just about creating a funny circuit and experimenting with a random idea and all. You can build your own idea by using this entire procedure that we have followed all the way 12 to 15 or 12 to 13 videos. Okay, so this is how we need to build a system. This is how we need to create an embedded system by using a Tinkercad, and also create a circuit, create code by using a Arduino IDE, which I have shown here, and you can explore whatever you want in this entire experiment. I hope you are going to build it by yourself and try it by yourself to change some parameters. For example, changing from 0 to 100 to 0 to 255, and experiment how exactly it looks like. Okay, so I hope you enjoyed it, and you are going to try it by yourself. Alright, this is the last episode of entire tutorial that we have came across. It has been around 12 to 13 videos about Arduino course for absolute beginners for 2021, and it is going to be a very helpful for 2022 people as well, and I'm very sure that this is going to be a very advanced one for your beginning stage when you are learning Arduino development board for the first time, and even Arduino coding for the first time. I hope you are enjoying the entire tutorial, and I hope you enjoyed the course of all these 12 to 13 tutorials that we have built for you, and you have built your own circuit and explored the maximum possible in this entire tutorial. So consider subscribing to our channel, link frequency, hit that like button and encourage us with sharing this particular tutorial series with your friends and family who are very much interested to learn Arduino for the first time. Tune yourself to make a difference.